11.5 Volumes of Prisms and Cylinders. Essential question: how can you find the volume of a prism or cylinder? How can you use the formula for density? Let's take a look at this stack of papers and find its volume. Volume, and a lot of you will use length times width times height. And the length will be 2 inches by 2 inches, and the height is 8. So the answer is 32 inches cubed. We're talking about volume. Now, when you twist the stack of papers, do you think it changes the volume? And the answer is no. We still have the same number of papers. So what we're talking about here, when the shape changes but the volume does not, that's called Cavalari's principle. And it states that if the cross sections are the same at every level, then the volumes will be the same, as long as the cross sections are the same and the heights are the same. Let's remember how we find the volume of a prism. What we do is we write down length times width times height. What I'd like you to think about is that the length and the width are really finding the area of this bottom part right here. Length and width, find this. And then you times by how many stacks you have, which is your height. Now, the reason I'd like you to think about area of the base times the height instead of length times width times height is because this will be easier for you when the base is not a rectangle. So in this case, the base is a triangle. You'd still want to figure out the volume by finding the area of the base and timesing it by how many stacks there are. And the same would be for this problem. Again, find the area of the base and times how tall it is, and so on. So let's get away from length times width times height, which is only good for a rectangular prism, and use a more versatile formula that'll help us find volume in lots of cases. And here's our volume formula. Let's go ahead and do a problem. What I like to do a lot of times is draw the base so that I can see the base. Now remember, bases are always parallel and congruent in prisms. And this looks like, I see a little red thing here, so I know it's a right triangle, and this is 3 and this is 4. So this is going to help me understand the area of my base. Volume is equal to the area of the base times the height, and when I talk about finding the area of the base, I'm going to have to use the triangle formula, 1/2 times base times height, and then I'm going to multiply it by the height, which is 2. Now I want to make a distinction between the B's that I'm using here. Now this capital B stands for area of the base, where this little b stands for just the length right here. So be very careful how you use your capital and lowercase. Now let's go to the next screen so you can see how I did the second problem. What I did is I drew the base, which is a trapezoid. And if you forgot the area of a trapezoid, here it is right here. I went ahead and put all the numbers in, times it by how tall it was, and I got my volume. All right, net is a pattern that you can cut and fold to make a model of a solid shape. The reason I want to talk about net is before we leave to the next problems, let's look at these problems that we had before, and I've changed the directions. The directions are now find the surface area. Now to find the surface area, what we want to do is we want to flatten the solid into the net. And then we want to find the area of each size, a triangle, and 3 rectangles, and then we get our surface area. In this case, I have 2 trapezoids and 4 rectangles that I have to add up. So that's how we find surface area. Okay, volume of a cylinder. This base is a circle, so that's why we're going to use pi r squared to designate what that area is. And so the volume of each cylinder, again, I like to start off with my formula. Volume is equal to base times height. Again, we're leaving behind length times width times height because that's no good for a base that doesn't have a length and the width. We're going to use our area formula, and then we're going to times it by how tall it is. And on the next slide, you'll see the results that I have here. Now, remember Cavalari's principle, even though this is leaning, it's going to have the same volume as a cylinder that's standing straight up like this, where we use 7 again as the height and 4 as the radius. All right, surface area of a cylinder. If you flatten it, the net looks like this. It's a rectangle with 2 circles. Now, the length of this rectangle is really the circumference. So that's why I wrote 2 pi times 9. That's going to tell you how long the label part of this cylinder is. And the height is 6. So to find the surface area, I'm going to find the area of the rectangle and 2 areas of circles. And when I find this, I get this answer. And we're not going to find the volume of this one right here. Okay, your turn. Take a minute to stop the screencast and see what you can do. And here are the answers. Again, it's a good idea to draw your base to help you. Using the formula for density. Density before was density of population. When we did density of population, it was number of people divided by area. Now we're going to be talking about density in terms of volume. And in this case, the density that we look at is mass divided by volume. All right, let's take a look at a standard gold bar. Now this standard gold bar is in inches, and we're being told that the density is in grams per cubic centimeters. So we want to convert the inches into centimeters, and here's the conversion. 1 inch is 2.54 centimeters. So I went ahead and converted each one of these dimensions here. The density is 19.3 grams per centimeters cubed. Mass, we don't know, that's what we're looking for. And then here's the volume. All I did was take these 3 values and multiply them together to get centimeters cubed. And when I cross multiply, this is the amount I'm going to get. Now remember, this is grams over centimeters cubed, so this will be grams over centimeters cubed as well. All right, your turn. Go ahead and stop the screencast and see what you can do. And this base happened to be a circle, so this is going to be pi r squared, and again I changed the r into centimeters and the height into the centimeters. So this is the volume of this cylinder, and we're given the density again, mass divided by the volume, cross multiply, and I get my mass. Let's take a look at finding what the height of this chest should be. Again, start off with your formula, write down what you know, and I know the dimensions of my base, which is 6 times 4, and when I solve for h, I get 3 feet. So that height will be 3 feet. Let's take a look at a 6-foot tall dresser whose volume is 36 cubic feet. Volume is equal to area of the base times the height. We know the volume, we know the height. What we don't know is the base. So I go ahead and divide, and I get the area of the base to be 6 square feet. Now they want us to give a possible length and width, and to create 6 cubic feet, one dimension could be 2 feet by 3 feet. Similar solids. Well, let's talk about similar figures first. The ratio of the perimeters is equal to the scale factor, or the ratio of the sides. The ratio of the areas in similar figures is the scale factor squared. So I hope it's not a surprise to you that when we have similar solids, when you want to compare the volumes, it'll be the scale factor cubed. Now here's an example of how we can do the problem. We want to find the volume of the large right here. So I write volume of the large over volume of the small, and then this scale factor cubed. And the way I'm looking at the scale factors, I'm comparing the large to the small. So it's 6 over 3, which ends up being the number 2. 2 cubed is 8. I cross multiply to figure out my volume. All right, your turn. Try to find the volume of prism D, which is a small prism. Stop the screencast. And here's the answer. Notice that the volume is much smaller. Find the volume of the concrete block. So in order to find the volume of the concrete block, I'm going to figure out the volume of this large prism, and I'm going to subtract 2 times the volume of each space. Each space is going to be the same. So here's the area of the base, which is right here, and then here's the height. So that's going to be the volume of the large block. Now each little space here is going to be 0.39 times 0.33, and the height is going to be 0.66. I'm going to times it by 2 because there's 2 of these spaces. And when I use my calculator, I get 0.4 cubic feet. Your turn. Stop the screencast and see what you can do. And here's the answer.